We have all seen examples in nature that demonstrate the importance of physical features in mate selection. From the long tails of peacocks to the impressive antlers of mule deer, it is well known that males are often dramatically ornamented in efforts to show off their fitness and secure mates. In this way, females are often choosy when it comes to mate selection because these impressive physical traits may reflect a greater ability of the male to secure higher quality territories, provide better parental care, and or pass on viability and attractiveness to his offspring. Does this ever happen the other way around, with males being choosy and females having to ornament themselves? According to the Differential Allocation Hypothesis, individuals should adjust parental care investment according to the quality of their current mate. This means that a male may adjust his efforts in protecting and feeding his offspring based on the attractiveness of his female mate. If there is a chance that the male will have better luck with the future mate in producing high-quality offspring, the male may not invest so heavily in the offspring he has with the poor-quality female. By displaying differential allocation of parental investment, males enhance their fitness by strategic partitioning of parental investment, improving the quality of their offspring. In a recent study, researchers tested the differential allocation hypothesis in male blue tits to see whether or not the males adjusted their parental care investment based on the ornamentation of their mate. In a study conducted by Dr. Katrina Marr, the quality of the female blue tit mate was determined by the UV reflectance of her blue crown. Females with a brighter crown are assumed to have greater fitness because the coloration is correlated with survival, reproductive capacity, better nutrition, and social status. Other studies have suggested that UV reflectance is an indicator of an individual's ability to afford the trade-off cost of time-consuming plumage maintenance due to having successfully allocated sufficient resources. Either way, carotenoid-based female coloration is positively associated with increased clutch size, fledgling success, and local recruitment, or the proportion of breeding birds that are locally born. This experiment was designed to determine if there was a significant difference in male behavior and to a lesser extent nestling size when the UV reflectance of females was reduced. The reflectance was altered using duck preen gland oil on both the control and experimental groups. The experimental group also had UV blocking chemicals in addition to the oil. The reflectance was determined using a USB 2000 spectrometer and halogen lamp, and the male behavior was then observed from 20 meters away using a spotting telescope. The researchers also used a rubber snake to observe the male's defense behavior. At the end of the experiment, nestling body mass was also measured. The results showed that the reflectance in the UV-reduced group significantly decreased, while there was an insignificant change in the control group's reflectance. There was a significant reduction of feeding trips in the male mates of the UV-reduced group, but no change in the female feeding trips of either group. Negative association between the laying date, as in it was later, and the size of the prey, as they were smaller, was also found in the UV group, but it was not significant. The differential allocation hypothesis suggests that in response to decreased parental care from one parent, the less attractive partner will increase their own effort. However, this is not the case here. The researchers have suggested that the females may already be giving their maximum effort and may not be able to compensate much for the male's decrease. In species with biparental care, males may gain benefits from choosing high-quality females and adjusting their parental investment to female quality. In other words, they may differentially allocate to enhance their own chances at reproduction in the future, so they don't waste energy on a female in poor condition who cannot produce high-quality offspring. Generally, this behavior might occur if 1. There is a large variance in female quality and affects offspring survival, 2. If males provide parental investment, or 3. Remating opportunities are low. The differential allocation hypothesis relates to animal development and reproduction. The evolution of sexual reproduction involves a trade-off of quantity over quality of offspring. Through natural selection, blue tits have developed methods to determine the quality of their partners by observing physical characteristics indicative of higher fitness. In these birds, a monogamous strategy, meaning one mate and parental care from both sides, for mating and parental care is essential in providing offspring with the care that they need, especially when chances for remating are low or so resources are scattered. Furthermore, study in this area may be beneficial to conservation efforts because consideration of animal attraction and behavior may help researchers understand how to benefit the conservation of declining species and more effectively supplement existing populations.